Hello students, myself Dr. Deepak Verma. Today we will discuss the design of anchor sheet pile. As we know, there are two methods to design anchor sheet pile. First, free earth spot method, and second, fixed earth spot method. And by these two methods, we can determine the embedded depth of sheet pile and anchor force in tie rod. Today we will discuss the fixed earth spot method. When anchor sheet pile is driven to a considerable depth, then its lower portion is practically fixed. As shown in figure A, the deflected shape of sheet pile. In this figure, there is no deflection beyond point G, and GC it remains vertical. So we can say it is vertical propped cantilever, where G is the point of fixity. Similarly, pressure distribution diagram and moment distribution diagram can be drawn. As shown in figure B, AB it is the height of sheet pile, C it is the point at the bottom, small g it is the point of fixity, small d it is the point of zero pressure. As there is no deflection beyond point G, so this GC it is replaced by a reaction R to simplify the pressure distribution diagram. In moment distribution diagram, as shown in this figure, below dredge line the bending moment is 0 at point I, and this point is called point of inflection or point of contraflexure. In fixed earth spot method, further there are two approaches for analyze the sheet pile. First is elastic line and second is equivalent beam method. The elastic line method, it is complicated and time consuming but accurate. On the other hand, the equivalent beam method, it is simple and quick, and in general we prefer equivalent beam method, and this method was given by the scientist H. Blum. The pressure distribution diagram is shown where ABC it is a sheet pile, AB it is the height of sheet pile, D it is the embedded depth of sheet pile below dredge line, D dash it is the depth of sheet pile up to point of fixity, that is G. Small y distance of point of inflection, small x distance of zero pressure point. In this analysis, the value of y depends upon the angle of shearing resistance. So y is a function of angle of shearing resistance, and we can determine the value of y from a chart as shown in this figure. So after simplification, the pressure distribution diagram is shown in figure E, where the lower portion is replaced by reaction RB. PA it is the active earth pressure at dredge level, and P2 it is the earth pressure at bottom. F it is the location of anchor rod. We can determine the value of PA if we know the value of gamma, that is unit weight of soil, and phi angle of shearing resistance, and the formula for PA is Ka gamma H. By determining this PA, we can determine the value of small x. The value of P2 we can determine, and the formula is gamma into Kp minus Ka into D dash minus x. In the equivalent beam method, a hinge is assumed at a point of inflection I, and so there are two independent beams as shown in figure F, AI and IG, and at I there are equal and opposite reaction Ri. We can determine the earth pressure at point of inflection by using this formula, by using the similar triangles. If we know the value of PA at point dredge line, what is the distance of this dredge line from D? It is x. Now it is P dash and the distance from D, it is x minus y. So by equating this, we can determine P dash upon PA equal to x minus y by x. So the design steps to determine the embedded depth and anchor force are: first of all, draw the pressure distribution diagram as shown in figure E, that is this one. Then determine the value of earth pressure at dredge line, that is PA, and the formula is Ka gamma h after calculating the value of coefficient of active and passive earth pressure. Then find the value of small x by using the formula. Then determine the value of y using the chart. For upper beam, compute the pressure intensity P dash by using this formula. Then determine the reaction Ri by equating the total moment about anchor rod Fa to 0. Then for lower beam, determine the pressure at the base, that is P2, by using the formula, this one. Then find the distance d dash minus x by equating the total sum of moments about G to 0. Then find d dash and then embedded depth, that is d equal to 1.2 times d dash. After that, anchor force we can determine by considering the upper beam, and for upper beam the force in anchor rod Fa equal to Pa minus Ri, where Pa is the total pressure of upper beam. By this design step, we can determine the embedded depth and anchor force in sheet pile using equivalent beam method.